Hi, so I have a student that goes to Westlake High School in Thousand Oaks. I believe it's Calculus AB, Chapter 3 exam review. This is question number 2. It's about linearization. So the question number 2 says, find the linearization. There's a keyword right there, L of x, given the function square root of x squared plus 9 at x equals -4. Okay. So let's try to figure this out. Before we start with linearization, I'm going to start with some information first. You always start with the point slope form. The point slope form says the following: y minus y1 is equal to m times x minus x1, right? You have your point, which is x1, y1, and you have your slope. That's why it's called the point slope form. I really don't like that y to the minus 1. I'm going to move the y to the minus 1 to the right-hand side so that I'm going to add plus y1. So that's equal to plus y1. That's your point for your x and your y. This is my tangential slope. Got it? And they also give you at x equals -4. And my function looks something like this. It's the square root of x squared plus 9. Y now, instead of calling it y, we can call it a linearization of x. Because we know that this is a linear function. This equation makes a line, in other words. I have to figure out what my slope is. My slope is my tangential function, as I said earlier. So I have to take the derivative of this. Before I do that though, my x1 is going to be -4 right here. And my y1, f of -4 is equal to square root of -4 squared is going to be 16 plus 9. That's equal to the square root of 25, which is equal to 5. Okay. My function, let's rewrite this in exponential state. X squared plus 9 to the 1/2 power. Now we're going to take the derivative of this. You take the power down and then subtract 1. Bring on the power down. X squared plus 9, the inside stays the same, times, I forgot to change to the exponent. Always don't forget to do the exponent. 1/2 minus 1 times the derivative of the inside. The derivative of the inside is the chain portion. The derivative of x squared is going to be 2x. The derivative of 9 or a constant is just 0, 2x. The 1/2 and the 2 cancels. This becomes, I'm just going to rewrite this. What's 1/2 minus 1? It's going to be -1/2. This goes to the denominator. This goes to the numerator. It's be x over and x squared plus 9 to the 1/2 power. The 1/2 power, I'm going to have to change it back into the exponential state. To change that to an exponential state, the denominator becomes the index of the radical, right? Let's go to x over square root, that's the 2 right there, square root of x squared plus 9. I have to find f prime of -4 though. So that's going to be -4 over square root. -4 squared is 16 plus 9 is 25. And so it's going to be -4 over 5. That's my slope, tangential slope. X minus -4 is going to be +4 plus 5. Distribute that out. You can keep it like this, or I would distribute this out because I believe the answer is going to be in distributed state. Because if you're in the wrong state, you're lost. So make sure that you're in the right state. -4/5 times x is -4/5 x. I'm going to distribute that. It's going to be -4/5 times 4. It's going to be -16 over 5 plus 5. Plus 5 is thinking is 5 over 1, right? We'll multiply by 5 to have a common denominator. -16 over 5 plus 25 over 5. That's going to be positive 9 over 5. So my linearization as a function of x is equal to -4/5 x plus 9/5. There it is right there.
That was easy.
So let's do a quick little recap. We start with the point slope form. They usually give you what the function is. You do have to take the derivative at a certain point. So once you find the derivative, you found the derivative value of the slope at x equals -4, our value, which goes in right over here, our slope. They also give you the point for your x, and yeah, sometimes you have to find out what your y value is, starting value, or sometimes they'll actually give it to you, okay? And then just plug it in, and then there's a little bit of algebra involved, uh, especially when you're taking derivative of power functions. So good luck on your exam.